The CERIAS Security Seminar from Purdue University. Today's guest is Dr. Myron Kramer, the founder and director of Essex IA Sector, a division of Northrop Grumman. Dr. Kramer has over 30 years of experience in government and commercial technology programs, and his background includes positions at Booz Allen Hamilton, SAIC, ARINC Research Corporation, and the Georgia Tech Research Institute. Please join me in welcoming Dr. Kramer.
Thank you. Today I'm going to talk to you about concepts in something called security architectures. I'm going to talk about the Enclave model for security architectures, as well as some reasons to go beyond the Enclave and to extend some of the concepts and the methodologies that are part of security engineering to include capabilities for new information system requirements. The overview of the talk is that the conventional model, the conventional Enclave architecture model, does not easily support collaboration, collaborative information sharing, things like web services and other needs that are evolving as part of things that people refer to as Web 2.0 or net-centric systems. The solution is to come up with more creative models or new ways to apply security concepts and to apply new technologies like virtualization to provide security and to develop new security solutions for some of these problems. The assumptions that are part of this talk are that we have a need for cross-domain information sharing. And when I talk about cross-domain, I mean across different companies, across different organizations, more than the typical single Enclave concept. And then I'm also looking at some of the new applications that are exciting on the internet today, things that are referred to under names like web services. So the topics that I'm going to talk about include the general concept of some of the problems that we're looking at, the approach toward security architecture and engineering, the kind of an introduction to the Enclave security model for those who may not be familiar with that, talk about how you end up typically implementing an Enclave architecture, and then some of the aspects of the cross-domain problem and some of the architectural ideas that we're working with in terms of how to implement cross-domain solutions. Talk a little bit about web services and the challenges that those pose, as well as some of the technologies that we have available to address these kinds of challenges. So the traditional problem in today's security world is how do you secure information systems? How do you control access to these systems? How do you implement things like a need-to-know type of policy? Today's conventional systems typically take an approach that, in general, people are denied access to information unless they have a validated need to know. And so they err on the side of denying access unless somebody can produce the appropriate credentials to gain access to these systems. So really the new challenge in today's world is how to satisfy collaboration. Things are not based on individual contributions to the degree that they have been in the past. We're looking at people working together, sharing information, sharing applications, the whole experience on the web today, the things that are exciting, with some of the new applications, really talk about making that information available to other people, other partners that you want to work with. And so we're really looking at a requirement to share. And so we're looking at how do you secure the need to share as opposed to securing the need to know. And there are different models and different concepts. And so there are new challenges with doing that. This is kind of a simplification of what's called the Enclave architecture. How many people have seen things like this before? Or is this something that is a generally new concept? Where you talk about having a DMZ or a service network that is physically separated from your internal network. On the left side of the diagram, you'll see public areas. So we're basically separating trusted users and trusted systems from untrusted areas. And then we have a separate set of parts of the information system that are accessible, and then the internal parts of that system are not accessible to outside or untrusted users. That's one of the basic concepts. The Enclave architecture has kind of been the gold standard for security architectures. If you're looking at what is the best way, the best model to build your systems, is to separate systems in this type of fashion. So what I'm going to talk about is really the whole process by which you come up with a solution for securing your information systems and how to implement those with off-the-shelf commercial products. So we really talk about the process of first an architecture and an engineering process where we translate the requirements into a design, and then we implement the design with products, and then we operate that in accordance with a business model that satisfies the things that we're trying to do. Together, as part of this process, we have something called defense in depth, where we have layers of protection. We control access to the people who need that access, and then we monitor that access, and then we respond to issues as they may be occurring. The starting point is really what are the policies or the requirements. One of the criticisms that I've seen for a lot of different systems is that people have not consciously thought about what is it they're trying to do. And so they tend to try to apply a cookbook solution, which may be the right solution for somebody else, but it's not the solution for what they're trying to accomplish with their system. And typically, the contractors who are brought in to build systems for large companies, for example, will be basically following some blueprint that is a generic blueprint, and that the best results follow when somebody has taken a conscious step of really stating and thinking through what they're really trying to do, and then coming up with the design that is tailored to that specific need, and then implementing it with products that are configured correctly. And so we're really looking at the right way to go through that whole process. So when we talk about security requirements, there are a number of ways to capture and describe security requirements, and you probably have seen these written up in different ways. So what I'm trying to do is keep this talk at a fairly high level that would be applicable across the board to many different applications. And the simplest way to think of security requirements is to break them up into three primary groups: things that relate to confidentiality of information, things that relate to the integrity of the information, and then the availability of the information. And one of the mistakes that's often made is to think only of confidentiality and to think that's security. Many systems that require security are not really focused on the confidentiality aspects of that. That may not be important. For example, if you go to a website that is maybe publishing information like a newspaper, there is no confidentiality. You want people to see it. You want them to read it. So what's important to you is that the information does not get altered, or that the website does not get hacked, for example, and that it's available, that when people click the button, it comes up. And you don't just get the site not available type issue, because your business may depend upon that e-commerce system being there to serve the customers. So when we look at confidentiality, there's a wide set of different things that make up confidentiality. Certainly access control is the obvious one, and there are different degrees of access controls depending upon your users. Are these people that are all trusted employees? Then if they are, then you may be happy with the standard Windows or operating system user accounts. That may be sufficient. Or you may require stronger access controls if you have both inside users as well as public untrusted users accessing the system. For example, if you have a website, you may have one level of access controls that's available to the general public, or to the outside users, and then a stronger level of access controls for the people who are administering or updating and changing the content on the page. Account management is important because if you don't keep track of who your users are in your directory, then how can you enforce their access controls? So that's one of the areas that's important for implementing confidentiality. And then, of course, the different ways in which you would authenticate people, whether it's just user passwords or whether you need biometric authentication or whether you need some kind of card, like a CAC card or a smart card. And then, of course, knowing who people are is only part of the problem. You have to be able to associate the privileges that go with the information. The data has to be labeled as to which things different users can have access to. Who owns the data? What is your procedure for backing up and recovering the data, for example? How do you store it? That type of thing. So those are all part of confidentiality. Integrity includes a whole set of things that are there to ensure that the information is not altered or can be restored if it is damaged or lost. And I think we're all familiar with backing things up and having a way to restore that. We also need a way to test that and verify that, as well as to protect information from being altered by viruses, worms, or other malicious content that might be trying to destroy that information. Of course, availability is important. If we have a service that our business depends upon, we may look at how are we backing up that information. Do we need to have a redundant site available online to handle the capacity so that we're not taken down by normal usage or by potential outages. We're looking at the contingency planning for disasters. You know, when Katrina hit, that affected a lot of systems that were operating in New Orleans. So you have to look at national, regional disaster type issues, depending on the nature of the business. Another thing that is also associated with some of these things is non-repudiation or accountability. If you're running an online e-commerce site, you need to be able to prove that somebody who placed an order with you really placed that order, so that if they deny it and say, I didn't buy that, you have some way of assuring yourself that you have measures to enforce that purchase to avoid fraud type of issues. And so when we're looking at how do we go in and now translate these into a design in our system that will satisfy these types of requirements, we're looking at some fundamental principles. And I'm just trying to highlight some of the major ideas here, that certainly these can be expanded into a lot more detail, depending on the nature of what you're doing. But the fundamental principle is separation. And when we talk about the enclave architecture, we could see quite obviously how the enclave architecture provides separation. It separates trusted and untrusted parts of the systems from each other. We're also looking at a least privilege concept where people do not have access to things that they don't need to have access to. External users accessing the public area of the enclave architecture do not need to have access to the internal systems. And then another concept that's a little more complicated is the one of interdependency analysis. And what we're looking here is that when we apply our security measures to our system, to our design, it doesn't do any good to apply it inconsistently across the system. So if I have some things where I'm applying strong security, and then we have other things that maybe have no security applied to them, then I have not treated that consistently. It's, for example, if I have a room and I put a very expensive lock on the door, but I have a glass window on the door that people can just punch out the glass, then obviously there's a lack of balance there in terms of the strength of the mechanisms that are applied. So when we apply security into a design, we're trying to have at least an equivalent level of treatment. I talked about separation as a fundamental principle. Really, in applying separation, we have to think about not just the data itself or the systems themselves. We have to look at the users of that information. In what way am I separating basically the trusted users from the untrusted users? In terms of how they connect to the systems, what systems they're allowed to connect to, and then the communication paths. What am I doing to protect the trusted communication paths from the untrusted communication paths? In terms of the responsibilities of the people, how am I separating those responsibilities? Do I have one person who is administering the system and is also doing the security management? Those should be different functions so that you don't have a single point of failure. If somebody makes a mistake, even if it was well-intentioned, there will be no opportunity to catch that if there's no other people involved in implementing that. And then we're looking at segregating the data both while it's stored as well as while it's being accessed. So, for example, if I have a public server, I don't want to use that same physical box for both my internal trusted uses as well as my external public users. I want to use different systems, different physical systems, and not just trust, the operating system to separate internal users from external users. So those are just basic fundamental concepts of doing that. And as part of, I mentioned the least privilege enforcement, the general concept here is that in general, access is denied to information except where you specifically need to permit it. Now we'll see later where that fundamental approach creates issues when you're looking at sharing information. And we already talked about interdependency analysis, that we need basically a balanced view of how they tie together. So when we're looking at implementing the architecture, we now go back and we take all the requirements that we've maybe listed on this system. And now we need to go back into, let's say, if you could imagine a drawing of your system, you should be able to take each of the requirements and identify exactly where in your design that requirement is being satisfied, whether it's being enforced by the firewall, enforced by an intrusion detection system if we're looking at monitoring, whether I have a vulnerability scanner that I'm using to basically assure that my system is configured correctly, that I have antivirus systems to protect me against malicious code, or that I have VPNs maybe to separate my trusted user communications from my untrusted users, that I can have systems to provide strong authentication where I need that, and that I have cryptographic systems to provide cryptographic separation of maybe some internal activities from public external access. So we're really looking at that whole defense in depth process and how we design a particular solution depending on what my application is. So the general approach is to have a formal way to first document what your requirements are and then to translate those into how they're actually built and implemented on the actual system that's being fielded. Now, when I look at all these different systems doing different things, one of the mistakes that's often made is to think that all of these systems provide protection. Turns out very few things provide any protection at all. A lot of other things provide measurement or provide supporting capabilities, but by themselves provide absolutely no protection. The only things that actually provide protection enforce the separation and apply the least privilege enforcement. Things like, for example, firewalls. Things like intrusion prevention systems that actually deny something from happening. Things that may be reviewing content and blocking content that's not satisfying certain criteria for me even being allowed into a system or out of a system. Things that are limiting access to a host. Things that are limiting your access to an application program like a database. Those are providing protection. If I have an intrusion detection system or a vulnerability scanning system, it's doing measurements, maybe useful information, But by itself, this intrusion detection system isn't going to stop anything from happening. It's just going to give you an alarm. If nobody's there looking at the alarm, it didn't do any good. And I know of many situations where people have had expensive intrusion detection systems that have detected attacks, but nobody was paying attention to them, and the systems were hacked or the information was compromised because the intrusion detection system didn't provide protection. All it did was provide information that you can use or not use. So that's important to recognize, is which things really actually protect. We go back to the Enclave architecture, and we can now take all of those things we were talking about, and we can map them into the drawing. And I can say, here's my mail server. My public mail server is on my DMZ. It can receive incoming mail from the outside internet. What protects that mail server? The firewall. How do I monitor that, attacks against that mail server? Well, if I have an intrusion detection system on the DMZ, it has the possibility to warn me about things that are happening. I have a proxy server or a VPN server. Those can provide portals to other activities based upon somebody authenticating. So when that untrusted user is out there on the internet, once they connect to these other systems and authenticate themselves, then they're trusted, and then they can be allowed access to internal resources. And so basically the Enclave architecture enforces those principles that we talked about in terms of separation and in terms of providing at least a place to hang the different security products to build an overall secure system. And overall, this model has been a very effective and strong model if we're talking about a single organization where I have people inside and people on the outside. And so while that's a good model, and can be implemented in either small or large applications, it's still based on that concept that I have one inside and everything else is untrusted and on the outside. And that's a very limited model for doing collaboration. But let's talk a little bit more about how you would actually implement policies within that model. And I'm just going to focus here on just to explain a little bit more about how this works. And I think this is important because in going through how this normally functions, you'll get some insights into its limitations also. So we're really talking about a system where you have this separation between the outside and the inside, or the external systems and the internal systems. So we basically have the firewall. Now, when you install a firewall, let me just ask, how many people here have actually worked with the firewall? Okay. On paper, it looks like they can do a lot of things because you can come up with some great ideas of what your firewall is going to do for you. The reality of it is you're into something like this. And this is a typical kind of interface that you have with the firewall. The only things you can really do with the firewall are the things that you have things to click and select and turn on or turn off. So you can't really come up with very complicated policies for the firewall to do because it really only does a certain set of things. It can't really, in general, discriminate, fine granularity of activities. Either you allow mail to, for example, that you can include, you can allow mail or you can deny it. You can allow the post office protocol or you can deny it. And those are the kind of things that you really have choices for. So they tend to be fairly limited in terms of the policies that they can do. And this is just a list of some of what those are in terms of the benefits of using a firewall. So in general, it includes more than just filtering packets and allowing them or denying them. It provides proxies. It'll provide a variety of logging information, and so forth. The typical policies that we're looking at for a firewall is to, if you look at the red X at the top, in general, deny anything trying to come directly into the system. It would typically allow access to the public servers on the DMZ, which is shown in the block underneath the firewall. It would also allow internal users on the intranet to be able to access the public servers, and it would allow internal users to have access to the outside world. But in general, the typical type of policies with the Enclave model do not allow external people to just directly access things on the internal network. That's the general concept that's implemented with that. So when we're looking at designing a system, when we combine the different products together, we're really looking at how much security can we provide, how much will it cost, and how complicated does that really make my system. And so if you really look at adding security, you always have to balance, well, how much do you really need? You don't want to go overboard and put extra products or extra restrictions on systems than what is needed, because it doesn't add the benefit that's needed for that extra complexity. One of the factors that comes in is really choosing the right products. And there are a lot of ways that people choose products. And I have found that in my own surveys that most of the ways in which people do this are wrong. They're not really the right kinds of thought process to follow. And I can't tell you how many times I have seen people select products based on magazine articles. You know, it could be a trade journal article. You know, it could be something like CIO Magazine or Information Week or something that all the IT people read. But basically, those articles are written by journalists. These journalists are not security professionals. They might know a little bit of the buzzwords. They might have, you know, had some experience in the past with information systems, but their opinions are driven by a lot of other factors other than the quality of the product. They're going to write articles about information that the marketing people give them, and also their main source of income is their advertising. So they're going to favor their advertisers. They're not going to slam their people who are paying their salaries. So in general, magazine articles are a horrible way to compare and choose products. User surveys. Well, it's the blind leading the blind. You know, a user survey, you know, just because a large number of people choose a particular product doesn't mean it's any good in the real world. You know, popularity. If you look at the most popular automobile, does that mean that's the best car that's out there? Probably not. It might mean it's the cheapest one, or it could mean that it's the one that has the best job of selling. And so user surveys, popularity, magazine articles are really the wrong way. There are a set of objective criteria. For example, the common criteria is publicly available information from the Defense Department, and these are formally tested products that are the certification reports are publicly available, and these give, you know, a good objective assessment that the product really does what it says it does, and that it has been tested and independently verified to have a certain level of quality. And you know, certainly advice of people who are actually in the security businesses is a good metric too. And so we're really looking at how strong is that firewall. What you're really measuring is how hard and how much effort would be required to compromise that product. And there is a great deal of difference between different products that are out there. So that's something to think about, is really how strong a product do you really need to satisfy your security requirements. So I'm going to now jump into the cross-domain issue. And we're really looking at the issue now of collaborating across multiple organizations, such as multiple businesses or between different user communities, and to satisfy the concept of sharing information as a requirement, and then how to integrate applications across different organizations. And the typical problem that we're looking at is two different user groups have a community of interest. And by community of interest, I mean some shared interest in a business or in an area. And they're really looking at sharing information across that. And so we're really looking at now how do I implement a solution that allows them to accomplish this without exposing either domain 1 or domain 2 to unauthorized access? The worst possible way is just to connect the networks together, because that allows everybody in domain 2 to access the information in domain 1 and vice versa. And so that really is giving too much access. So this is a complicated problem. And so when we really look at linking together some of these functions and sharing information, we have to think about what is the business model that I'm trying to satisfy. So we're really looking at the functions. And within each of these domains, we have to think beyond just the TCP/IP networking layer. We have to look at what is the functions that are being done. What plans are being done. I can think of each domain as a machine. The machine has a plan that it's implementing, a set of processes, a set of databases, and a set of people. I can't forget the people that are part of that domain. So together that comprises the business model of domain 1, and I have the same thing for domain 2. So I'm looking at which processes need to talk together, what databases or what portions of the databases need to be shared, and then which respective users in each of those domains need to access that. And then the degree to which the plans or the objectives of domain 1 and the plans and objectives of domain 2, what do they have in common? What do they have differences? For example, if these are two companies and they're engaged in a joint venture, which is a complicated type of transaction, they have areas of mutual interest, but then they also have competing interests. So in coming up with my design for that system, I really need to separate those two things, because you don't want to compromise the areas where they need to share, and I also don't want to compromise the areas where they don't need to share. And so to do that, we have to think about the different parts of the problem. And one part of the problem is, of course, the things that happen within each of the local domains. The other part of it is what happens in the interconnecting system. And the interconnecting system can be a VPN between the systems. It could be the internet. It could be an SSL session. It could be a variety of ways in which we communicate between the two domains. And we have to distinguish the security policies that apply to each one of these three different things. Now, I'm showing a case of two different domains. If I have more than that, you can see that the problem becomes more complicated, because you have a factorial mathematics at work here. And so you could very quickly end up with combinations of things that would overwhelm a simple enclave architecture. You can't just implement this in a set of firewall rules. You really need to think through the design of how to implement that. The other point is I have to actually look where I transfer responsibility from local domain 1 to the interconnection system, and then from the interconnection system back to domain 2. So the transfer points are places where I have to pay particular attention to how I hand that responsibility off. And so those are all part of coming up with an effective design. So when we look at a cross-domain model, this diagram is really a nice, simple way to think about it and make it something that is easy to build. I can distinguish different parts of that system. The user, his workstation, the network in domain 1, the servers in domain 1, and then my boundary systems like the firewalls that are part of providing and brokering that interconnection. You think back to that list of security requirements. For example, there's one for maybe screen lock. Screen lock is an obvious security requirement. If, let's say you're a bank and you have a teller at the bank and she's at her terminal, if she walks away, anyone can come and conduct transactions as if they were her. With screen lock, that console is locked, and so that system is protected by a password that has to be re-entered when that session is resumed. It's the same thing if it's a doctor at a medical center, in terms of protecting the private type of information. There's only one logical place to do screen lock. It's not the firewall. The only logical place is the workstation. So So if I go back to my original list of requirements, whether it was confidentiality, integrity, availability, I can put all of those on little cards. And I should be able to stick that card on some picture of where it's being done in my system. And if I'm careful about where I do that, I don't end up imposing a requirement on a device that can't do it. I don't want to try to do screen lock on a switch or a firewall. It doesn't make sense. You know, the only logical place to do that particular requirement is on the workstation. Separation of roles. We talked about separating the security administrator from the system administrator. The only place I can do that requirement is at the user level in terms of the rights and privileges I grant to users. I can't implement that anywhere else. You know, so if you think through your requirements, you can easily map them into the logical component to implement that, and now you have something that makes sense in terms of an integrated system. Okay, now if we have a more complicated system and we look at multiple domains sharing information, I have multiple boundaries. So if I think about my enclave architecture again, I have different boundaries. I have 3 different enclaves in this picture, but then I also have the overall integrated system. So we're really looking at where are my trusted users, where is my trusted information, and where are my untrusted applications. So to make it more complicated, let me talk a little bit more about this thing called web services. And some of the other terms that you'll see are things called SOAs, service-oriented architectures, or sometimes you'll see things called net-centric systems or net-centricity, where you're really talking about linking together the systems. This is a busy chart, don't worry about reading it, but what we're really looking at is the way we use the internet is changing. And we have seen, even within a fairly short period of time, major changes in the way we use the internet. From the original command line type of interactions with hypertext that were just textual links, to the graphical browser, which really popularized the internet because it was point-and-click type of functionality. And when the graphical browser first came out, people had to keep their homepage or some list of links, because there wasn't any way to find out where things were. And so you ended up having to type in a URL. Most people don't type in URLs anymore because they have other ways to find things. But back in the early graphical browser, you had to know the list. So what became very popular early on to fill that need were portals. People would go to portals like Yahoo or to other places that would be lists of links. And those very quickly evolved into search engines, which provided more of a dynamic way to keep up with the internet. And in terms of the changes. And today, a lot of activities still are done by going to Google and typing in what you're looking for. If you're looking for CERIAS, instead of trying to figure out what the URL is for the CERIAS webpage, you just go into Google and type CERIAS, click return, and bing, up at the top, and you click it, and there you go. And you're trusting the search engine to get you to the service that you're looking for. Well, with web services, that model changes now. And with the XML protocols, you have a different way of connecting things that you don't have to go and search for things anymore. Within this architecture, services register themselves, whether they're data sources or applications that are available on the internet. You basically, the process becomes more transparent to the user and easier to function. And that's becoming very popular. The one that is in widespread use now is the RSS protocol, which is really a very simple model for a push type technology. But the whole series of XML protocols really provide a standards-based way of implementing services-oriented architectures, where part of a program can run on one system, another part of the program can run somewhere else on the internet, they can exchange information. And so we're really looking at this as the way of building those kinds of applications that can share information and can collaborate. Go back to this drawing again. And now think about all these protocols running, XML. We have a standard way to define information, a standard way to define application services, a standard way to register and communicate those, and a standard way to exchange data across different programs. We can now provide a set of functionality that really crosses all of these different domains. So the question is, how do you secure that? How do you ensure that that service that registered itself with you is the authentic service and is not an imposter? If you're doing banking, how do you know that's really your bank? You see things with the phishing attacks that are going on. You see things with identity theft. That becomes even more of an issue when you talk about releasing and relinquishing greater amounts of control to things that are going to happen more automatically. So I think these provide a lot of challenges. So how do we do that? How do we actually, as a service provider, apply that? And so one of the approaches is to look at some of the new technologies. Well, in looking at the way things have transitioned, we've gone full circle back to data centers again. So data centers are now part of our solution space. We used to have these big, huge mainframes. Those transitioned into the distributed computing model and desktop computing. Now we're into PDAs. So now, instead of actually using a computer, I may be just using a handheld device. I probably will be using something like an iPhone or a BlackBerry or something that will be a thin client type of architecture, and the real programs and the real information are out there somewhere on some infrastructure. And so we were really looking at, when we talk about this whole information sharing, of how do we do that? How do you secure your data centers? Well, we have to get away from just that simple model that we were talking about with the basic enclave. Because if you're in a data center, you don't really have a physical enclave anymore. You have an identity and a presence at the application level on the internet, and that may be actually a shared resource that is used by different organizations. And virtualization is one of the technologies. So we go back to this kind of a drawing on the left. The traditional way of implementing those principles for the enclave are done through physical boxes. I have a separate box that's my web server, a separate box that is my internal directory service, a different box that's my file server. So basically every single component in the basic enclave model is a separate physical box. But in today's world, these can all be running on a very small number of servers that are running VMware, and they could be running as virtual machines. Now, in my organization, our infrastructure runs virtualized. And so we have hundreds of computers that are running on a small number of actual physical boxes. It provides a level of separation, a level of security that ends up making it more complicated for somebody to compromise that. It allows you to still pick up a lot of the separation ideas that we were talking about, satisfying the requirements, but now satisfying them in a way that allows you to program different communities of interest. So the implications are that we can integrate things, we can manage them in a more central fashion, and we are now taking advantage of the manageability that we get through virtualization. But there are risks with that, because now I'm trusting my virtualization system to provide that separation. And yet I'm really sharing memory space, if you look at what's really happening among different virtual machines, and integrating my security products there also. So if we're looking at really how do I protect that virtualized infrastructure, we're into issues of how do I ensure confidentiality, integrity, availability of the virtual machines. how do I take advantage of non-persistent file systems that are part of those technologies? How do I refresh virtual machines if needed? How do I build virtual firewalls and virtual switches that I can have that same level of control and manageability of? And then how do I detect where I have virtual infrastructures versus true separation? So what I've really outlined with the need to go beyond the traditional enclave model is really how to apply some of these concepts, keeping a lot of the disciplines of security engineering as a way of satisfying some of these new demands for cross-domain and information sharing. And so I guess at that point, if you have any questions, I'd be glad to discuss that or any other topics of interest. I know I threw a lot of information at you in a short period of time, but I was trying to really provide a complete self-contained talk on a timely topic relating to things that are happening on the internet. So, yes?
Myron, you deal with an awful lot of large enterprise
Yes.
networks, commercial and within the government
Yes.
industry. What are some of the common things that you think that I thought we would be beyond this already, that common recurring problems that you see?
Well, I think there are several common recurring problems. One of those is just first what I would call understanding the information landscape. Just knowing where are the networks, where are the systems, understanding where the users are, where the servers are. Most of the large enterprises that I've worked with are such and are so extensive and have evolved so much that people have lost track of the topology. So that is a very common problem, whether it's a government or a commercial customer. Just knowing where are things is a challenge, and it's very hard to keep up with that because the infrastructures are so complex today. Purdue University's network. Do you know what it looks like? Do you know where the servers are? You may know where some of them are, but do you have the big, complete picture? Does anybody? I mean, it's a very complicated thing. You throw in VPNs, and now you have very complicated topologies where you don't really have an enclave concept anymore. You have a Klein bottle where you don't have an inside and you don't have an outside. And so a lot of large enterprises topologically aren't closed at all. And so you really can't do an enclave security model for them at all because they don't really have an inside or an outside to protect. So that's one common problem. Another common problem is dealing with change. We're looking at an IT environment where the companies, software companies and hardware companies are coming out with so many new products and capabilities that it's impossible for anyone to keep up with it all and to be current on those issues. And so one of the challenges for large companies is how to keep up with that. It's a lot easier for a small company to keep up with changes than it is for a big company. Big companies typically have large legacy databases, and anytime they change something, whether it's just changing a user from Windows XP to Vista, they don't know what the impact is in terms of what applications that'll break, because they have so many things that are very complicated. So that's another common problem for large enterprises, is dealing with that. Yes?
One question. As far as, for example, just to make a simple example, a session hijacking attack.
I'm sorry, which?
A session hijacking attack.
Okay, now, are you supposed to?
I turned it on.
Oh, okay, good. A session hijacking attack, yes.
In this case, what is let me say, the added security provided by the virtual machine environment?
Okay. Well, virtualization by itself doesn't add, security. It's really how do you use that as a tool in designing and building your system so that you can provide separation. So in the case of a hijacking attack, we're probably not concerned with separation there is the issue. We're primarily concerned with authentication. So I would say that particular issue would best be addressed with how am I maintaining my directory, how am I, what am I using as an authenticator for that session. If I set up, for example, even something as simple as an SSL encrypted session, that provides a degree of security against somebody intruding on that particular session. Yeah. Another thing that would prevent somebody from hijacking that session would be session control constraints on the firewall. If you're dealing with an application firewall as opposed to just a router filters, if it sees that, let's say, a user session does not have activity on it, it'll close that session. If you have a web, even an encrypted web session, and there's no actual activity, it will close that. So the user will have to re-authenticate if they come back to that. And I think we've seen that in many applications. If you're, for example, on an e-commerce site, you're in the middle of maybe doing a banking transaction, and you go away and you do something else for a while, and you come back and it says your session is timed out. And the reason they're doing that is to keep somebody from discovering the session and coming in and trying to capture that session. So virtualization, I don't think is, a component there, but the other things probably would be standard ways of handling that. I don't know. Does that answer your question? Okay. Other questions? Ideas? Thank you.